All right, so good morning. This question is from electrostatics. The topic is capacitance. Now, capacitors are used, okay? Capacitors are used for storing charge and electrostatic potential energy. Okay, these are the two main uses of potential energy. Okay, now let's look into the problem. It's a parallel plate capacitor. So capacitance is given by epsilon naught A by D. Two plates are separated and the medium between them is air. Okay. Air is also a dielectric. These are the two parallel plates. Okay. And you can show them like this also. The capacitance is decided by area of the plates, which is this. It is decided by the distance between the two plates and the permittivity of the medium between them, which in this case is air. The part one of the question is, what will be the capacitance if the distance between the plates is reduced by half? So let's write this, that the D has been reduced to half. So the initial capacitance is 8 picofarads, right? This is what you can see. Now let's put the value. Okay, so the capacitance is given by epsilon naught A by D, which means 8 picofarad is given by epsilon naught A by D. Question is, if the distance between them is reduced by half, what is the new value? So let the new value be x, and now the medium has not been changed. The permittivity remains the same, A, and now the distance between them is reduced to half, right? So let me do, this is equation number 1, this is equation number 2, dividing 1 by 2. So 8 by x is equal to epsilon naught A by D, epsilon naught A by D by 2. So 8 by x, right? This goes away. You're left with D upon D by 2 is equal to 2. So x is given by, the distance has been reduced, right? So 8 by x is equal to 1 by 2 and x is equal to 16 picofarads, right? So if you reduce the distance, capacitance is inversely proportional to D. If D reduces, the capacitance increases. Let's go to the second part. Okay, in the second part, if you see, a dielectric has, all right, so in the second part a dielectric has been introduced, and if you see, the new dielectric is having a dielectric constant of 6. So if you have a parallel plate capacitor and you introduce and fill this with a dielectric, okay, you fill this with a dielectric, what happens is the new potential difference between the plates goes down by the value of K, which is a dielectric constant. So if you've introduced a dielectric whose dielectric constant is 6, your new potential difference will be V naught by 6. So the introduction of dielectrics, if this is your dielectric which has been introduced, will reduce the potential. So at a lower potential, you will be able to save the same quantity of charge you were able to save at V naught. Okay. Now the capacitance is given by epsilon naught A by D. And since your dielectric potential has gone up, you will write this as K epsilon naught A by D. Okay. This is your C new. Okay. And this is your C old. And you know how much is this? This is given to be 8 picofarads. So K, which is a dielectric, 6 into 8 is equal to 48 picofarad. So you can go and watch my playlist where I have given, I think, around 100 numericals, more than 100 numericals and concepts on electrostatics and capacitor, electric field and Gauss theorem. You will find it very useful for your entrance examination and the concept. This is the only channel in the country which is giving explanation of what we are doing. We're not applying the formulas blindly. We want that students really learn the topic conceptually and have clarity. So thank you very much for your time and wait for my next video.